In the name of God, I'm Reyhaneh Loni from Tarbiat Modares University, Tehran, Iran. It's my pleasure that I can present our paper as titled Nusselt number prediction for oil and water in solar tubular cavity receivers. Here you can see table of contents including abstract, introduction, methodology and description, result and discussion, and conclusion. First part, abstract. In this paper, a dish concentrator with different shapes of cavity receiver including hemispherical, cylindrical, and cubical cavity receivers was numerically investigated with thermal oil and water as the working fluids. Different shapes of cavity receiver were studied under the same operating conditions for prediction of the internal heat transfer coefficient correlation for each cavity receiver. Some equations were suggested for prediction of Nusselt number with variation of solar radiation, flow rate of the working fluid, and inlet temperature of the working fluids. The result revealed that the hemisphere cavity receiver had the highest cavity heat gain, heat transfer coefficient, and Nusselt number values compared to other investigated cavity receivers. Introduction. Some researchers investigated thermal model of solar dish concentrator with cavity receiver. Unit all investigated and optimized a new structure of dish concentrator. They presented equations for designing the novel dish structure with the highest performance. Unit all investigated and an optical and thermal performance of a dish concentrator with a new shape of cylinder cavity receiver. They investigated different parameters for optimization performance of the solar system. They found selective optical properties of the system can be accounted for as an effective parameter for increasing performance of the system. On the other hand, some researchers were studied convection heat transfer of the working fluid in the solar systems. For example, some researchers studied convection heat transfer in microchannel based on laminar flows. Water and air were used as the working fluid. They presented some Nusselt number equations for the investigated system. Who et al. Developed a numerical model for the simulation of silicon molten salt nanofluid in the solar system. They predicted an average Nusselt number that shows a good agreement with the experimental test. Zhang and Yang considered a numerical model for prediction of heat transfer of air in vertical channel. It could be seen from the literature review. There is no reported research related to the prediction of Nusselt number for different shapes of cavity receivers. Consequently, prediction of Nusselt number of the dish collector using different shapes of cavity receiver is a novel subject for research. In the current study, the influence of various parameters such as solar radiation, inlet temperature, volume, flow rate of the working fluid is investigated. 3 types of cavity receiver, including hemispherical, cubical, cylindrical cavity receivers, are numerically simulated. Thermal oil and water are examined as the working fluid. The Nusselt number of different investigated shapes of cavity receiver using various investigated working fluids are predicted based on the developed numerical model. Methodology. A schematic of the investigated solar system with different cavity receivers presented in this figure. You can see here we have a dish collector with three shapes of cavity receiver, including cylindrical, cubical, and hemispherical cavity receivers. The dish concentrator with tubular cavity receivers was used as a solar dish reflector that you can see here some optical and structure parameters of the solar system, including solar dish reflectivity of this amount, tracking error of 1 degree, optical error of 10 meridian, and some other structure parameters that you can see here for the dish concentrator and different shapes of cavity receiver that you can find more detail related to this parameter in the paper. It should be mentioned that the modeling of this study was done based on 2 steps, including optical modeling and then thermal modeling. In the first step, we present some detail related to optical modeling. The optical performance of the solar system was investigated by Salt Ray software based on the developed optical analysis in the salt rays with flux distribution along the cavity tubes and absorbed solar heat flux by the cavity walls were estimated. A view of the optical analysis of the dish concentrator with 3 investigated tubular cavity receivers is presented in this figure that you can see here. Related to thermal modeling of this system was done based on energy balance equations and thermal resistance method that you can see general equation of this modeling here, and you can find more detail related to this equation and this modeling in the paper. It should mention that the thermal performance of the solar system for prediction of Nusselt number was numerically developed in the Maple software using writing code. Validation of the system was done based on experimental data that were measured and reported in the paper reference 19 for the same dish collector with cylinder cavity receiver that you can see a view of them here, and there is a good agreement between the measured experiment data and calculated data at noon when the system is at the steady state condition. Results and discussion. It should mention that analysis were done based on comparison of 3 cavity receiver and comparison of 2 different working flows that used in this study. In the first step, we present calculated results related to conversion of 3 cavity receivers. It should mention that default value of the solar radiation, flow rate of the working flow, and inlet temperature of the solar working flow were assumed as these values that you can see here. Also, variation of the solar radiation was done in the range of these amounts, and flow rates of the working flows were investigated between these amounts and inlet temperature of the working fluid was investigated in the range of these amounts of the working fluid, including for oil and for water. You can see these amounts, these values for water and these values for oil. Here you can see the result of the cavity heat gain for 3 different shapes of cavity receivers. It can be seen the hemisphere cavity receiver had resulted the highest cavity heat gain compared to other investigated cavities for all of the investigated conditions. It could be concluded that the cavity heat gain had increased with increasing solar radiation, increasing flow rate, and decreasing inlet temperature of the working fluid. Also, there is an optimum values for the flow rate of the working fluid, nearly 30 milliliter per second for 3 investigated cavity receivers that can be saved. Request energy for pumping oil with achieving the highest thermal performance. Here you can see variation of heat transfer coefficient with variation of solar radiation, flow rate of the working fluid, and the temperature of the working fluid for different shape of cavity receivers. The highest heat transfer coefficient was calculated for hemisphere cavity receiver for all of the investigated conditions. Also, it could result that increasing solar radiation, increasing heat transfer coefficient in the meaningful manner. On the other side, a variation of flow rate and inlet temperature of the solar working fluid has not shown a significant difference in values of heat transfer coefficient. Here you can find variation of Nusselt number amounts for variation of solar radiation, flow rate, and inlet temperature of the oil. You can find hemisphere cavities has resulted the highest Nusselt number amounts compared to other investigated cavity receiver that followed with cylinder cavity and final cubic cavity receiver for all the investigated conditions, and the variation of them you can see third of them. Here you can find a predicted equation for Nusselt number in different conditions that more detail of them has been presented in the paper. And as we mentioned, these analyses were done for 2 working fluids including water and oil, and you can see that water as a working fluid had absorbed higher thermal energy compared to thermal oil as the working fluid. Also, it was concluded that the cavity heat gain improved with increasing solar radiation, increasing flow rate, and decreasing inlet temperature of the working fluid. Also, the highest cavity surface temperature was estimated for application of oil with the highest solar radiation, lowest flow rate, and the highest inlet temperature of the working fluid. Also, it was resulted the application of the water as solar working fluid had resulted the higher values of the heat transfer coefficient compared to water one. Also, the heat transfer coefficient improved with increasing solar radiation, increasing flow rate, and decreasing the temperature of the solar working fluid. Finally, it was found that hemisphere cavity receiver had resulted the highest cavity heat gain, heat transfer coefficient, and Nusselt number values compared to other investigated cavity receiver for all of the investigated conditions. It could be concluded that cavity heat gain, transfer coefficient, and Nusselt number amounts had increased with increasing solar radiation, increasing flow rate, and decreasing the temperature of the working fluid. Some equations were suggested for prediction of Nusselt number with variation solar radiation, flow rate of the working fluid, and in the temperature of working fluid for 3 investigated cavity receiver with thermal oil. Also, it was found water as a working fluid. Working fluid had absorbed higher thermal energy compared to thermal oil at all investigated conditions. The highest cavity surface temperature was estimated for application of oil with the highest solar radiation, lowest flow rate, and the highest inlet temperature of the working fluid. It was resulted application of water as the solar working fluid had resulted in higher values of the heat transfer coefficient compared to oil. It was concluded that application of thermal oil had resulted in higher amount of Nusselt number compared to water as the working fluid. Consequently, use of oil is suggested for high temperature system. Thank you for your attention. Bye.